So welcome to Electron 6 layer. So we are in PYQ of signal system. That is the event semester 2024 and 25. Okay. Uh, so in this section we will see next four number of 6 mark questions. Okay. So this is the question. That is to find the linear convolution between the two sequence, that is 2 1 minus 3 and 10 8 2. Okay. So x of n equal to 2 1 and minus 3. Similarly, y of h of n equal to 10 8 and 2. So this is the convolution, that is y of n. That will be x of n convolution integral, that is h of n. So this is the formula. So y of n equal to k from minus infinity to plus infinity, x of k h of n minus k. Okay. So now length of the input sequence, that is 3. You can see this is the length of the input sequence, that is L. This x of n, the length is 3. Similarly, length of the impulse response, that is m. In this case, h of n, what is the length? So it will be 1, 2 and 3. So length is 3, that is m. So what will be the length of the output sequence? That is n is equal to L plus m minus 1. So that will be 5. Okay. So now, what is the starting point? So starting point, you can see both the sequences are starting at 0. Okay, so that is why this xl equal to 0, hm equal to 0. So 0 plus 0 equal to 2. In this case, both the sequences are ending as 2. So 2 plus 2, that will be 4. Okay. So now, y of n equal to this one. So let us find out what is y of 0. So y of 0 equal to x of k into h of minus k. So if this is x of k, this is our h of k. So h of minus k means that is the time reversal or time folding. So this is our h of minus k. So let us multiply this x of k with h of minus k. Okay. So you can see there is y of 0. So at 0 the value is 2 here. At 0 the value is 10. So that is 2 into 10, it will be 20. So there is no other common points. So minus 1. There is no minus 1 over here. Minus 2 also, there is no minus 2. Similarly, 1, there is no 1 at h of minus k, and 2 also, there is no 2 at minus k. Okay. So that will be 0. So only common point at 0. So that will be 2 into 10, that will be 20. Okay. Similarly, y of means 1 we can find out. So it is x of k into h of 1 minus k. So now h of 1 minus k is obtained by shifting h of minus k towards the right by 1 unit in time. So this is our h of minus k, that will be shifted towards the right. Means it will be minus 1, 0 and 1. Okay. Then it will be multiplied with x of k. Okay. So that is our x of k. Let us multiply this. Okay. So this is the common, let us say how many common points are there. So 0, the value is 8, here 0 is 2. So 2 into 8. Similarly, at 1 it is 10, at 1 it is 1. So 10 into 1, it will be 26. Okay. So next n equal to 2, y of 2, so that will be h of 2 minus k. So h of 2 minus k is obtained by shifting h of 1 minus k towards the right by 1 unit in time. So this is our h of 1 minus k. So let us shift that towards the right by 1 unit time. So this is 0, 1 and 2. So that will be multiplied with x of k. So this is our x of k. So let us multiply. So you can see how many common points are there. There are 3 common points. So at 0 it is 2, at 0 it is 2. So 2 into 2. Similarly, at 1 it is 8, at 1 it is 1. So 1 into 8. At 2 it is 10, at 2 equal to 8 it is minus 3. So 10 into minus 3, it will be 26. Okay. So at n equal to 3, so it is y of 3 equal to x of k into h of 3 minus k. H of 3 minus k is obtained by shifting h of 2 minus k towards the right by 1 unit in time. So this is our h of 2 minus k, that will be shifted towards the right by 1 unit of time. So you can see that this is our h of 3 minus k, that will be multiplied with x of k. So how many common points are there? You can see common points are only 1 and 2. So let us multiply that. So at 1 it is 2, at 1 it is 1. So 2 in 1 into 2. Similarly, at 2 it is 8, at 2 equal to it is minus 3. So 8 into minus 3 equal to minus 22. Okay. So next is at n equal to 4. So it is y of 4, that will be x of k into h of 4 minus k. So h of 4 minus k is obtained by shifting h of 3 minus k towards the right by 1 unit in time. So what is our h of 3 minus k? This is our h of 3 minus k, that will be shifted towards the right. So let us check that. So this is our h of 4 minus k. Only the time axis will be shifted. You can see that will be our 2, 3 and 4. Okay. So that will be multiplied with x of k. So common point is only 2. So 2 then minus 3. So 2 into minus 3, it will be minus 6. Okay. So now let us this is our x of this not x of n. Okay. This is our means, so we have calculated this y of 1, okay, y of n. So let us check this by tabular method. Okay. So this is our x of n, that is given as 2 minus 2 1 and minus 3, h of n equal to 10 8 and 2. So let us multiply this 2 into 10, so that 20, 2 into 8, that will be 16, then 2 into 2, that will be 4. Okay, similarly, this 1 into 10, that will be 10, 1 into 8, that will be 8, so 1 into 2, that will be 2. Similarly, minus 3 into 10, that will be 13, then minus 30, then it will be minus 24 and 6. So let us add this, okay, diagonally. So you can see 20 is there, 20 is there, so it is 20. Similarly, 10 plus 16, what that will be 26. Similarly, this will be added. So that will be 12 minus 30, that will be minus 18. So this is our minus 22, that will be minus 6. Okay. So our answer is correct. By we can check by using the tabular method. Okay. So this is first 6 mark questions. Okay. Let us check then another one. So in this case, you have to discuss the unit step rectangular unit ramp function with mathematical and graphical representation. Okay. So I have actually drawn for the means continuous time signal. You can draw also for the discrete time signals. Okay. So unit step signal, actually u of t, that is defined as u of t equal to 1 for t is greater than equal to 0, 0 for t is less than 0. Okay. So in this case, this is our u of t. You can see at 0 it is 1. For greater than 0 also the value is 1. Okay. But is less than 0, the value is 0. This is our u of t. Similarly, unit ramp function signal, so it is denoted as r of t. So it is defined as r of t equal to t for t is greater than equal to 0 and 0 for t is less than 0. So you can see for t is less than 0, the value is 0. Actually, these values are 0. Okay. These values are for less than 0, it is 0. And for t equal to 0, it is 0. For t equal to 1, it is 1. For t equal to 2, it is 2. Likewise. 3, it is 3. 4, it is 4. Okay. So like that. Likewise. Okay. So this is our r of t or unit. This is a ramp signal. Okay. Next is your triangular signal. So rectangular pulse. So you can see it is defined as x of t equal to r rect t upon t, capital T. Okay. Where capital T is the period. So you can see a and t are the amplitude and width of the pulse respectively. Width means this one. Okay. So it is minus t by 2 to t by 2. That will be width is your t. Okay. So amplitude is your a. Okay. In this case, the amplitude is a. Okay. So this is our means rectangular pulse. Okay. Third question is that how the discrete time systems are described by the difference equation. You can show the discrete time signal that can be described the system that is described by the difference equation. In this continuous time, that is a differential equation. Okay. So you can see there is a recursive. We can check. This is the for we have a recursive system. That is these are the called the difference equation. So y of n. So how to describe this? So y of n means this is the z minus this is a unit delay means. So if we have the y of n, so output will be y of n minus 1, and that is multiplied with a. So that will be a into y of n minus 1. So this will be added means there is a adder circuit. So this output y of n equal to x of n plus a of y of n minus 1. Okay. So this is a y difference equation. Okay. Let us say let us compute for y of n, that is for n is greater than equal to 0. So if we put n equal to means 0, so y of 0 equal to x of 0 plus a of y of minus 1. So y of 1 equal to, we can put n equal to 1 over here. So actually equation is that y of n is equal to y of n equal to x of n plus a of y of n minus 1. So in this case, if you put y of 1, that will be x of 1 plus a of 1 minus 1, that will be 0. Okay. Similarly, y of 2, that will be x of 2 plus a into y of 2 minus 1, that will be 1. Okay. So let us put x of 2 plus a into, in place of y of n, that we put x of n plus a into y0. Okay. So x of 2 plus a into x1 plus a into a, that will be s square y0. Similarly, x of 2 plus a into x1 plus s square, in place of y of 0, we can put x of 0 plus a into y of minus 1. So that we can put over here. So it will be a square x0 plus a cube y of minus 1. So if we rearrange this, it will be a3 into y of minus 1 plus a square into x of 0 plus a into x of n plus x of 2. So in general, we can write y of n equal to, you can see this is our y of n. So y of n, so y of n equal to a to the power n plus 1, okay. A to the power n plus 1. This is our actually y of 2. Y of 2 means this is n, this 2 means it will be n plus 1, that is 3. So that is n plus 1. Similarly, this is y of minus 1, this is constant. And s square. S square means this same n, that will be n. Okay. Similarly, over here, x0, x1, that will be a of n minus 1. Means here the y of 2, it is the y a to the power of 1. So n minus 1. Here is 1 means it is decremented by 1. That is n minus 1. Likewise, we can go, okay, up to x of n. Okay. So in general, we can write a to the power of n plus 1, okay, y of minus n plus this one into x of n minus k. So we have, in this case, we can see this output values are there. In this case, the input values is there. Okay. So you can divide it into two parts. There is a first part. This is a second part. Okay. Let us see. Check that. So response of the system y of n consists of two parts. The first part contains the term y of minus 1 that we have seen. This is a result of the initial condition of the system. The second part is the response of the system to the input signal. Second part, we have the x of n. So this is the response to the system to the input signal. Okay. So if the initial system is relaxed, that is for n equal to 0, the memory should be 0. In this case, y of minus 1 equal to 0. In this case, the recursive system is relaxed, okay, with 0 initial condition. So this is called the zero state condition. When y of minus 1 equal to 0, the system is at the zero state, and the corresponding output is called zero state response or forced response. It is denoted as y of zs. Okay, zero state or forced response. Okay. Similarly, for zero state, the forced response, this is the equation. Because y of minus 1 equal to 0. That is why we have this equation is your zs. Zero state is response equal to this one. Okay. Next, we learn the second part, that is the initial system. It is not relaxed. Then the output is a system with zero input. That is called the zero. This x of n equal to 0 means the it is at zero input. Okay, this system is at zero input, so it is the zero input response or natural response. It is z denoted as z I. That is zero input. Okay, so this is our second part. Okay, this is known as your, in this case also x of n equal to 0. Okay? So the total response of the system is by the zero state and the zero input response. Okay. So the general form of the recursive system is described by this this linear constant coefficient equation. This is this one. Okay. So this is how the discrete time systems are represented by the difference equations. Okay. So second one is means this is the third question, I think. Describe the properties of continuous time Fourier series. Okay. So you have to describe all the properties of continuous time Fourier series. Okay. So the x1 linearity, first property is linearity. If x1 of t and x2 of t denote the two periodic signal with period t, which is the Fourier coefficient as C1n and C2n. So x1 of t, the Fourier series is just C1, coefficient is C1n, and C2n is the Fourier series coefficient of x2 of t. Then in case of linearity property, a of x1 of t plus b of x2 of t, the Fourier series coefficients will be a into C1 1n plus C2n. Okay. So let us find out. This is the Fourier coefficient, that will be Cn equal to 1 upon t 0 to 2 x of t e to the minus j n omega t dt. So 1 upon t, in place of x of t we can write a x1 of t plus b into x2 of t. So a we can keep constant. So 1 upon t x1 of t e to the j n omega t dt plus b into 1 upon t x2 of t e to the minus j n omega t dt. So this is our Fourier series of coefficient, that will be C2n. This is a Fourier series coefficient, that will be C1n. Okay. So this is a linearity property. Second one is the time reversal property. So the if time period t of a periodic signal is x of t remains unchanged when the time is for reversal. You can see the time period of x of t, and the when you do the time reversal, the time period means constant. Okay. So let us check that. So x of t, the Fourier series coefficient is Cn. X of minus t, the Fourier series coefficient is C of minus n. While in this case, the time period is same. Okay. So let us check that. So Cn is the 1 upon t 0 to t x of t e to the minus j n omega t dt. So only x of minus t. Okay. We can Fourier series coefficient we can find out. Let us check that is Cn minus. Okay. Let us Suppose it is Cn minus Cn dash. Okay, that will be 1 by t 0 to t x of minus t e to the power minus j n omega t. Now let us take t minus t equal to tau, so minus dt equal to d tau. So Cn prime equal to 1 by t 0 to minus t x tau e to the, you can change the limit also. Okay, e to the minus j n omega tau minus d tau. Similarly, we can have this will be plus. We have changed the limit, so that will be plus. So minus c to 0, so this will be this one. Okay, so this is your c minus n. Okay, so you can see here the time period will be same. In this case, the time period how much? So upper limit minus 1 lower limit. So it will be 0 plus t. That will be the t. Okay. So the c means minus n also the time period is constant. C n also the time period is t. So in this case, the time period is remain constant. But the Fourier series coefficient is c of minus n in case of this means time shifting. Okay, sorry, time reversal. Okay, but means in case of this Fourier series, that is the Cn. Okay, but in case of if you go the time reversal, then it will be minus t. That will be c minus n. Okay, x of t the Fourier series is coefficient is Cn. If we go the time reversal, that will be x of minus t. That will be c minus n. Okay, but the time period is means unchanged. Okay. Here a time shifting property. So if x of t is the periodic signal, if the time shift, here also the time actually is preserved. Okay. So x of t, the Fourier series of c of n coefficient, and x of t plus minus t 0. If there is a plus, you can see there is a plus. So it is a, let us check that j n omega t 0 into cn. Okay. So let us check. This is our Cn. So 1 upon t 0 to t x of t e to the minus n omega t dt. So Cn dash that will be 1 upon t 0 to t. You can see we have checked t minus t 0. Okay, e to the minus n omega t dt. So let us take this t minus t 0 equal to tau or something like that. So t minus t 0 equal to tau. So dt equal to d tau. Okay. Let us put that. So you can change the also little limit also. So minus t0 to t minus t0, because you can see over here limit is previously it is 0 to 2, 0 to t I think. So if t equal to 0, if t equal to 0, this tau equal to minus t0. Okay. Similarly, it at t equal to t, so it will be t minus t0. Okay. So it is the minus t0 and t minus t0. Okay. So it will be x tau e to the power minus j omega. So n plus of small t, you can write it is t0 plus tau. So small t is t0 plus tau d tau. Okay. Now we can multiply this x tau e to the power minus j omega tau. This is e to the minus j n omega t0 d tau. Okay, so let us kept outside. This is e to the minus n omega t0 kept outside. So it will be 1 upon t minus t0 to means this is t minus t0. So x of tau e to the j n omega tau. So this is our actually Cn. Okay. So you can see also here the time period is remain constant. So in this case, with the time period, you can see t minus t0 upper limit minus lower limit is minus of minus t0. So this will be t minus t0 plus t0. So here also the time period is t. Okay. So here the time period is t. Okay. Previously x of t also the time period is t. That is why the time period is preserved. Only difference is that you can see it is multiplied by this one e to the minus j n omega t0. Okay. So we have taken the minus term, so this is minus. If you take the plus over here, it will be here as a plus. Okay. So this is our time shifting property. Next was your time scaling property. So in this case, if x of t is a periodic signal with time period t, then x of at, where a is a constant, you can see a is a multiply means constant. That will be called the scale factor. So that will multiply where a is greater than 0. That will be periodic with t by a is the time period, and the fundamental frequency is a omega. So in x of t, the Fourier series coefficient is ct with period t, and x of at, the Fourier series coefficient will be cn with period t by a. So here the means frequency is omega. Here the fundamental frequency is a omega. Okay. So let us check that. So Cn is the formula, continuous time Fourier series coefficient. That will be Cn equal to 1 upon t 0 to t x of t e to the minus j n omega t dt. So t prime, let us take t prime equal to t by a. So t prime with t means it is omega equal to 2 by t 1. So omega prime equal to t 2 pi by t prime. So that will be t prime equal to t by a. So it will be a into omega. Okay. So let us check that. So c n prime, it will be 1 by t prime, it is 0 to t prime, x of a t e to the power minus j n omega prime dt. Okay. Now we can put what is t prime, that is t by a. So it is 0 to t by a. So x at t e to the minus j, that is omega prime or omega dash, that will be a omega. So a into omega dt. Okay. Now it will be, let us take a t equal to tau. So a into dt equal to d tau. So dt equal to d tau by a. We can put over here. So 1 by a by t 0, y by t. So 0 to t. We can see x of tau e to the minus j n omega a. This is the value of means t. That will be tau by a. Okay, this is the value of t. This is tau by a. This is dt equal to d tau by a. Okay. So this a I think will be take outside. So this a and a get cancelled. So it will be 1 upon t. This a and this a will be also get cancelled. Okay. So you can see this a and a get cancelled. Okay. Then also this a and get cancelled. So that will be x of tau e to the minus j omega tau data. So you can see it is Cn. So you can see both are same. Only difference is that in this case also the time period is same. Means time, you can see in this case the time period is t by a. Okay, and the frequency is your, at the frequency is your a into omega. Okay, so this is the property is known as the scaling property, time scaling property. Okay. Now differentiation in time. So x of t, the Fourier series coefficient is Cn. Then dt into x of t, the Fourier series is Jn omega into Cn. Okay. So or d k into x of t by dt k, that will be Fourier series is it will be exponential of k. Okay. So let us check that. So x of t equal to summation of n is this is the Fourier series. So you can see minus n plus n Cn e to the jn omega t. So now dxt by dt, that will be derivative of this one. So what is the derivative? So Cn equal to k plus it will be means jn omega into this one. Okay. So you can see Cn into this derivative. So it will be jn omega into e to the jn omega t. So you can write here dxt or dt equal to jn omega. Okay. This is the jn omega. Okay, into Cn. So this is the differentiation property. We can check for square, it is this one. It is a k. Okay. So anyway, so this is the difference property. Then conjugation property. Then x of t with the Fourier series of Cn. So what is the x star of t? The Fourier series is your coefficient is c minus n, that will be star. Okay. So Cn, the Fourier series here coefficient is 1 upon t 0 to 2 x of t e to the minus j n omega t dt. So if we take conjugate both sides, it will be Cn star, that will be 1 upon t 0 to 2 x star of t. That will be plus. Okay, we can say that will be plus. We can conjugate in both sides. This Cn star also 1 upon t 0 to 2 x star of t, that will be plus if we take the conjugate. So for if we replace n by minus n, that will be c minus n star to the 1 by t 0 to 2 x star of t e to the minus j omega t dt. So you can see that will, this is the means conjugation property. So last one you will see integration property. If x of t, the Fourier series coefficient is Cn, and that is the integration minus into t x tau d tau equal to continuous time Fourier series with Cn divided by j omega. Okay. So let us prove that. So x of the Fourier series is your x of t, n is minus infinity plus infinity, Cn e to the power j omega t. So let us take t equal to tau. So you can see t equal to tau. Okay. So now if we integrate this, it will be minus infinity plus infinity. Cn will be kept outside. Integration of minus infinity plus infinity e to the power j n omega tau d tau. D tau is not there. Okay. So it will be d tau. Okay. So if we integrate this, it will be j n omega divide, you can divide j n e to the minus j n omega tau in minus 1. Okay. So this is the integration property. Okay, of Fourier series, continuous time Fourier series. So these are the references. So in the next class we'll see the remaining 6 mark questions. Okay. So thank you all. So if you have any doubt, you can feedback in the comment section. Okay. So thank you all. Have a nice day.